All right, good morning. So we are going to talk about solving our logarithmic equations. We got to remember a few different properties here. You're condensing, you're expanding properties, and anytime I've got a log equals a log, I can take the stuff inside the logs and set them equal to each other. So 5x equals 2x plus 9, since I've got the same base 10 if it's not shown. And then 3x is 9, x is 3. So why don't you guys try 2 through 5, pause the video, and then check back here in a second, see how it went. All right, now I've got the same base again. So 10 minus 4x equals 10 minus 3x. So we can add 4x. 10 equals 10 plus x minus 10, x equals 0. Same thing, I've got the same base, so 4p minus 2 equals negative 5p plus 5. Let's combine our like terms. So we can add 5p. 9p minus 2 is 5. 9p is 7. So p must be 7 over 9. All right, same thing here. Got a base 10. So common logarithm base 10. (4k minus 5 equals 2k minus 1. Combine our like terms. 2k minus 5 equals negative 1. 2k equals 4 after I add 5 to both sides. K equals 2. And down here, same thing. Negative 2a plus 9 equals 7 minus 4a. Combine our like terms. 2a plus 9 equals 7. Minus 9 on both sides. 2a is negative 2, a is negative 1. And then here's where we've got to start using some of our properties, writing things in a different format. So anytime I have a log equals 0, I'll have to write that in a different format. But first, let's condense this log. So we've got a number out front, and what do I do with a number out front? Put it in the exponent. So, you know what? Make this a different color. Log base 7 of negative 2r squared equals 0. And now we have to write this in exponential form because I have a log equals a number. So base of my exponent is the base of the log. So 7 to the 0 equals negative 2r squared. Or 1 equals negative 2r times negative 2r. All right, so 1 equals 4r squared. How do we get the r's by themselves? Divide by 4. 1/4 equals r squared. And then to get rid of the squared, we can square root, and r is just 1/2. So why don't you guys take a second? I want you to, first things first here in number 7, get rid of that negative 10 to get your log by itself. And then we can write that as an exponent and then solve. So we can add 10 to both sides. So log base 3 of n plus 3 equals 0. And then we've got to write this in exponential form. So base of my log is the base of the exponent. 3 to the 0 equals n plus 3. 1 equals n plus 3. And then if I subtract 3 from both sides, n is negative 2. Okay, number 8. We need to move this number that's out front. Because it's out front, we can put that out here in our exponent. So 7x to the negative 2. And then do the same thing here, where we write this in exponential form and solve. Or, if you wanted to, you could divide by a negative 2 on both sides and then solve. You'll get the same answer. But let's look down at 11 and 12. That's where our problem type changes a little bit. You guys don't need to do 11 and 12. Don't need to do 13 and 14. But 15 through 18. I want you to do 15 through 18. So what we've got to do here first is we have to condense our logs. And if I'm adding, then I'll multiply the stuff in the logs together. So 1 log of 8 times x equals 2. And what base do I have if it's not shown? It's a base of 10. So 10 to the second equals 8x, or 100 equals 8x. And then we can solve. So you know, why don't you guys try number 17. So pause the video, try 17. And then we'll talk about 16 and 18. Or you know what, why don't you try 16 as well? Yeah, try 16 as well. So 17, adding, so I'll multiply the stuff in the logs. So log of 2 times x equals 1. Again, this is a base 10 if it's not shown. So 10 to the first equals 2x, or 10 equals 2x. So I can divide by 2, and x is 5. And now 16. If I'm subtracting, what do I do with the stuff in the logs? Well, I've got to divide it. So log of x divided by 2, again that's base 10, equals 1. So 10 to the first, or 10 equals x over 2. And how do I get rid of dividing by 2? I can multiply by 2. So 20 equals x. And 18 is a little bit different. I'm still adding two logs together, so I'll still condense with that shortcut. But then I'll have a log equals a log. So let's see what happens here. I've got adding, so I'll multiply, so 7 times x, or 7x, equals log of 37. If I've got a log equals a log, then I can just say 7x equals 37, or x equals 37 divided by 7.